Dear students, I hope you are all well and studying in your home. Last week we were discuss about the analytical chemistry in which we just introduce the chapter and different color of salts and their solutions. Use of ammonium hydroxide in analytical chemistry. I hope you will be understand till this topic. Today we see the action of ammonium hydroxide on certain salt of solution. Okay. Ammonium hydroxide forms insoluble hydroxide when treated with certain metallic salt solution. So ammonium hydroxide, what is formed? It forms insoluble hydroxide. Okay. When it's treated with the metallic salt solution. The insoluble hydroxide thus formed get precipitated in the form of a precipitate and may be identified by their distinct colors. Some precipitated metallic hydroxide become soluble on addition of excess of ammonium hydroxide. This is due to the formation of a soluble complex salt in the presence of excess ammonium hydroxide. The action of ammonium hydroxide on certain metallic salt solution is briefly described below. So, first it forms calcium salt solutions. So, calcium salt solutions are colorless and consist of calcium ions. When ammonium hydroxide is added to a calcium salt solution, a dull white precipitate. Okay, you have to remember that a dull white precipitate of calcium hydroxide. Calcium hydroxide is obtained. This precipitate remains almost insoluble even in the presence of excess of ammonium hydroxide. For example, you can see here that calcium chloride, it is a colorless solution of calcium and colorless ammonium hydroxide. When they both react, they form calcium hydroxide dull. Okay, dull white color. Calcium chloride react with ammonium hydroxide and it form calcium hydroxide dull white color. And ammonium chloride, it is also colorless and it is soluble in water. And next, calcium nitrate, when it react, it also form calcium hydroxide and ammonium nitrate, colorless soluble substance also formed. Next reaction with the iron salt solution. Iron with valency second or ferrous salts and iron or ferric salt. Okay, I already told you that when there is valency is second or 2, it's at ferrous, and when it is 3, it is said to be ferric. Behave differently when their solutions are treated with ammonium hydroxide. Okay, so they behave differently means different compound will be formed. First is iron second or ferrous salt solution. Iron second or ferrous salt solution are usually of pale green color and consist of ferrous ions. When a ferrous salt solution is treated with ammonium hydroxide, a dirty green precipitate of iron hydroxide or ferrous hydroxide is obtained. Okay. This precipitate is insoluble in excess of ammonium hydroxide. For example, you can see here iron sulfate, it is pale green solution, react with ammonium hydroxide and its form iron hydroxide. Dirty green PPT or precipitate is formed and ammonium sulfate is formed. And when it react with the ferric salt solution, what will be happen? Iron or ferric salt solution are usually of yellow color and consist of ferric ions. When a ferric salt solution is treated with ammonium hydroxide, a reddish brown precipitate of iron 3 hydroxide or ferric hydroxide is obtained. So you can see here in first one, iron hydroxide dirty green color will be formed, but in when the valency of iron is 3, it will be formed reddish brown ppt. Okay, FeCl3 iron chloride yellow solution react with ammonium hydroxide and it will form iron hydroxide reddish brown ppt and ammonium chloride. And then iron sulfate is react with further reactive with ammonium hydroxide and it forms iron hydroxide reddish brown precipitate and ammonium sulfate, which is colorless and soluble. Now we see what will be happen when lead salt solution is reactive with ammonium hydroxide. Lead salt solution are colorless and consist of lead ions or Pb plus 2 ions. When a lead salt solution is treated with ammonium hydroxide, a white precipitate of lead hydroxide PbOH whole twice is obtained. This precipitate is insoluble in the presence of excess of ammonium hydroxide. For example, lead nitrate plus NH4OH ammonium hydroxide, it forms a lead hydroxide white precipitate and ammonium nitrate. It is colorless and soluble. Next, copper or cupric salt solution. When copper with the valency of 2 or cupric salt solution are usually of blue color. Okay, when cupric 2, if you talk about cupric 2, it is usually of blue color and consists of cupric ions. When a cupric salt solution is treated with ammonium hydroxide, a pale blue precipitate of copper hydroxide or cupric hydroxide is obtained. This precipitate is soluble in the presence of excess of ammonium hydroxide due to formation of a soluble complex salt. For example, when ammonium hydroxide is added to copper sulfate solution, a pale blue precipitate of copper with a valency of 2 hydroxide is obtained. Copper sulfate plus ammonium hydroxide, it forms pale blue precipitate of copper hydroxide. And if ammonium hydroxide is further added drop by drop to access a soluble complex salt, tetraamine copper sulfate or cuprammonium sulfate, okay, is obtained, which is of deep blue color. Okay, it is of pale blue color, but it is when excess of ammonium hydroxide is treated, it will form a tetraamine copper sulfate, which is deep blue in color. Okay, you can see here reaction also. Now we see the reaction of zinc salt solution. Zinc salt solution are colorless and consist of zinc ions. When a zinc salt solution is treated with ammonium hydroxide, a white gelatinous precipitate of zinc hydroxide is obtained. White gelatinous substance or precipitate. This precipitate is soluble in presence of excess of ammonium hydroxide due to formation of a soluble complex salt. Okay, you have to remember that whenever excess amount of ammonium hydroxide is given, it the precipitate is soluble or insoluble. Following examples illustrate the complex formation. First, when ammonium hydroxide is added drop by drop to the colorless aqueous solution of zinc sulfate, a gelatinous white precipitate of zinc hydroxide is obtained. You can see zinc sulfate colorless solution reactive with ammonium hydroxide and it form zinc hydroxide. Okay, and if ammonium hydroxide is further added drop by drop to access a soluble complex salt, tetraamine zinc sulfate is obtained, as you see in last reaction with copper. This complex salt is colorless, therefore the solution becomes colorless. So this is the tetraamine zinc sulfate, a soluble colorless complex is formed by the reaction of zinc hydroxide with excess amount of ammonium hydroxide. Similarly, on treating a colorless solution of zinc chloride with ammonium hydroxide added drop by drop, a gelatinous white precipitate of zinc hydroxide is obtained. This precipitate dissolved in excess of ammonium hydroxide to form a colorless soluble complex tetraamine zinc chloride and a colorless solution is obtained. So you can see zinc chloride reactive with ammonium hydroxide, it forms zinc hydroxide, white gelatinous precipitate, and zinc hydroxide when react in excess amount, it forms zinc tetraamine zinc chloride. Okay, so this is the reaction with zinc chloride of ammonium hydroxide. So students, in your book the table 4.23 is given in which action of ammonium hydroxide on certain salt solution are given. Okay, so you can see it is a table in which briefly described the different salt solution and which ions is present and what color of solution and when it react with precipitate formed addition of ammonium hydroxide, which type of precipitate is formed, and what is the color of this precipitate, and solubility of ppt in excess of ammonium hydroxide, it is soluble or insoluble, and complex formed, if any, if complex formed, and its color if it formed in excess of ammonium hydroxide. So there are examples also given. Okay, so briefly these are given. You can read them and understand easily and try to learn also. Okay, so like as we read about the action of ammonium hydroxide on certain salt solution, next week or next class we will discuss about the action of sodium hydroxide on certain salt solution. So if you have any query or any confusion till this topic or anything you want to know, you can ask me. Okay, thank you.